which that makes life good. Yeah, we're doing 1.6 right now. Yeah, we're not learning anything new. 1.6 is like a review topic. We're taking what we've learned, we're putting it into a little bit of context, we're solving some equations, which is just review. So 1.6 is actually a pretty nice. If we look at this, it says, what do you remember about solving algebraic equations? This is an algebraic equation. If you're asked to solve it, what does it mean to solve an algebraic equation? Solve for x. It means isolate your variable. Isolate x. Which means get x by itself all to one side. How you decide to get there is your choice. I'm going to go the way that feels most efficient to me. If I want to move all my x's to one side on this question, it means I want to move this 13 x's to the other side. Because that way the x's are all on one side. This plus 32 is going to be on the other side by itself, so we're about halfway. How am I going to move 13x from the right to the left? I'm going to subtract 13x. So, there's 13x on both sides. And we should get 5x is equal to 32. Yeah, good question. We should get 4x is equal to 32. We don't want 4x by itself, we want just x. So how do we get that 4 off that x? We divide both sides by 4. Remember, when you're doing these things, what you do to one side, you do to the other. This means x is equal to 10. And these questions should be pretty relaxed at this point. Okay, B. Solve for x. You want to get x by itself. You need to get rid of this 4 first. So to get x by itself, you're going to move things away from it, starting with division, multiplication, and then working your way through that, essentially. So we move this 4 over here by multiplying both sides by 4. So cancel, cancel. We have 3x minus 5 is equal to 24. What's the next thing we want to get rid of? The 3 on the outside. The brackets first. So we want to divide both sides by 3. What cancels on left? Could you FOIL? Yeah. Good question. If you chose to FOIL, that's fine. You're just going to have to divide out your 3 later on anyway, because it would give you 3x on the inside. Like I said, there's going to be a lot of routes to get there. I'm going to try to show you what I think is the most efficient. It might not be, but it's just what I'm comfortable with. I think is how my brain works. So, divide both sides by 3. You get x minus 5 is equal to 8. What do we have to move still? Plus 5 to both sides, yep. And you should get x equal to 13. God. What else? We're going to get that. We're going to get that. And what it is, it's a lot easier than you think it's going to be. Okay. For C, that's no longer an equal sign. Does that change things? No. For this question? No. In future questions, potentially. And I'm going to tell you what it could change. If you have a less than or equal to sign. So I'm going to tell you that -1 is less than or equal to 5. Okay? That's true, right? I'm going to make that, negative. Actually, no, we'll leave it as -1. That's a true statement. -1 is less than or equal to 5. That's true, right? I know, this is why we're doing less than or equal to for a reason. This is an example of why this matters, and you're probably going to want to pay attention, because we're not going to do an example like this again. No, I want to show you why the less than or equal to sign matters. What if you multiply both sides by -1? Multiply by -1, that gives you 1. Multiply by -1, that gives you -5. Is that a true statement? No. So if you multiply or divide by -1, you flip the sign. Any negative, even or odd. Yeah, just any negative, if you're multiplying or dividing, you flip the sign. We don't do a question like that, but it could pop up. So you need to know that if you multiply or divide by a negative, you flip the sign. Because that isn't true. That would be true. Okay, we'll do this example, which is nice and easy. If you're not multiplying or dividing by negative, don't do anything to the sign. It just stays the same. So, what do we have to move on this question? The 7 over. Subtract 7 by both sides. And we get x is less than or equal to -2. That's your answer. This one. I'm going to move, actually I'll move the 5 over. I wouldn't normally, but I will here, because it'll show you something. So, subtract 5y from both sides. It cancels over here, and then we get -2y is less than or equal to -9. What? Yep, 3y's minus 5y's is -2y's. Okay, we need to get rid of that -2, so we divide both sides by -2. Divide by -2. Divide by -2. And we get y. What do you do the sign? Flip it. It's greater than or equal to 9 over 2. Why did I flip the sign? Because I divided by a negative. I divided both sides by -2. So I flip the sign.
You don't flip the sign if you don't divide by a negative.
Correct. The only time that this sign changes the question is if you're dividing or multiplying by a negative. Gain it. Hey, that's a good question. Because that's how I would have done the question initially. Because I hate it. Nope, it's positive because -9 divided by -2. The negatives cancel. A negative divided by a negative is a positive. So, Kaner says if we do the question the other way, which is what I would have wanted to do, we're going to subtract 3y from both sides. Subtract 3y. And we get 0 is less than or equal to 2y minus 9. I'm going to add 9 to both sides, and then divide by 2. So add 9, then divide by 2. And I'll get 9 over 2 is less than or equal to, sorry, just y, because I divided by 2. So it's the same thing. That's why we put this on. Yeah. So if you did it the other way, without dividing by negative, you get the same answer still. It says y is greater than or equal to 9 over 2. The only trick you need to remember, the only thing this is showing you, is if you have a sign, whether it's a greater than or a less than or anything like that, if you multiply or divide by a negative, you switch that sign. Don't forget that. Okay. Now that we've done the easy, the basic stuff, let's put some radicals in there and see if we can't make us hate that a little bit. So, we're going to throw some radicals in there. Here is a slide with some nice step-by-step instructions on how you should solve for a variable if you have a radical. The problem with this, in my opinion, is it just gets so complicated because there's instructions for if you have one radical, there's instructions if you have two radicals, there's instructions if you have radicals at the bottom. Like, there's just so many different sets of instructions. This is nice to have for reference. But at the end of the day, you're just going to have some good algebra skills and a good understanding of what you're doing to be able to solve these consistently. you're not going to be able to come to a test and write my step-by-step instructions. It's just not going to happen. The best way to do these is do a lot of them and do them without any instructions. So you've got it down. So you're good at algebra. It's really not much different. And I'll show you why. So the step-by-step instructions say isolate the radical. So you're going to move the radical all by itself. So you don't have like a radical x plus something. You're going to move everything away from the radical sign. You're then going to square both sides, or cube it if you needed to. In this class, we're only ever going to have to square things, so that makes our lives a little easier. We square it because it'll get rid of the radical sign. Part 3 is basically just solve it like you'd solve any question. Back.
When you're rooting something like so it's x rooted,
Yep.
when you square it, square just moves over. It doesn't it's not x squared moves over, it's just squares.
Yeah, we'll show you. You need to see some examples.
Okay.
The one other important thing is the bottom. You see a fancy word there. Extraneous. Extraneous groups. What is that? So extraneous means roots that couldn't possibly be the right answer. That's all it means. I like to think of it as extra roots. They're extra. The answers are extra, meaning that they aren't correct. They aren't possible. You're going to get answers that aren't possible. Which means, and this is what I'm going to show you, because that's just part of math. So, if you look at this question right now, you have the square root of 2x minus 1 plus 5 is equal to 2. Could x, just for fun, be 0?
No.
No. If x was 0, you'd be square rooting it negative. Is that possible? No. But when you do all your algebra, every once in a while you're going to get an answer that if you actually use that answer, it wouldn't work. Yeah, so why is that? That's a good question. Why is that? The reason that is the way it is because then this statement must not be true. It's not an actual mathematical statement. Another way to look at it is you'll get multiple answers to things. So you might get x could be 2 or 4. And then you'll figure out, oh, it can't be 4, but it can be 2. So that has to be your answer. Now, for example, you guys did these last year. We just called them something different. Remember when we would do our problem-solving questions and we would say, Jim studies and he gets an extra 5% for every amount he studies. How much should he study if he wants to get 80% on his test? And you would work out your solution and you would get, he needs to study 10 or negative 10 hours. And you would always cross out the negative 10 because that made no sense, right? It's the same thing. That was an extraneous root. That's not a possible answer. You can't study negative hours. You can only study positive hours. It's the same idea. They're just taking math and they're putting it in context. And as much as in this course we touch on it a little bit, it's important to understand that there's answers that don't exist because in Math 30 they constantly give you answers that don't exist. And you need to know which ones are which. Aaron.
So in the answer, that's what it's just changes and then it does exist, or you just
You just X it out and you say, no, that's not an answer. So the best way to do is do some questions. And we'll get some extraneous roots throughout this. So we'll talk ourselves through it. But let's do space ones. So we have 3. Root x is equal to 5. They tell us step 1 is to get the radical by itself. So our goal is to get just this by itself. What do we need to move away from it? The 3. Divide both sides by 3. That'll cancel. And then you have the square root of x is equal to 5 over 3. That was easy if we were looking for the square root of x, but we actually just want x. So how do you square? Square both sides. You guys have been doing this before. It's not that scary. Square root both sides. Sorry, square. Don't square root. Square both sides. That'll get rid of your square root. So you now have x equal to. What do we do with that square? You distribute it into both things. So it becomes 25 over 4. I squared the 5 and I've squared the, sorry. Another 2.
Good one.
And you square the 3. That's a good question. So, if we look at this right now, can you reduce that?
Yeah.
What's it reduced to?
5-3.
No. If you're ever wondering, if you get a fraction answer and you want to reduce it, math bracket. 25 divided by 9, math bracket. That should be the simplest form. Nothing divides 25 and. That's your answer. Now, before we move on, it's too square. The question you ask yourself every time when you're done a question is, does this ever make sense? If I took 25 over 9 and I plugged it in there, would it work?
No.
Can you take the square root of a positive 25 divided by 9? Yes. So yes, this does work. This is a good answer. That's a good habit to get yourself into. Okay, let's do one that's a little bit harder. Okay. The trick is to get the radical by itself. What are we going to have to move away from the radical to start?
4.
The 5. So, why is it a good question? And here's my answer. When you're trying to solve for something, we're used to doing bedmass. When you're trying to isolate for something, reverse bedmass. And another way to think about it is, if you ever can't remember the trick, here's the answer. If you want to divide by 4, right? So it cancels out.
Yeah.
You would also have to divide that 5 by 4, because you divide everything by 4. So the 4s would cancel here, but now you'd have a 5 over 4. And that's going to be a pain, right? If you want to see that one more time. Okay. Talking about, because people want to do the 4 first.
Okay.
Put it in brackets. Because that one side is all together. So if you want to divide by 4, you're dividing that entire thing by 4. So the 4s won't cancel. It won't work out. That's why we reverse bedmass. Okay, Bailey's got the right answer. We're going to add 5 to both sides to start. Plus 5, plus 5. You now have 4 square root x plus 1 is equal to 8. Now we can get rid of that 4. So divide both sides by 4. Divided by 4, divided by 4. You'll have the square root of x plus 1 is equal to 2. So, hey, when we have questions, we'll put our hands up. Bailey. That's a great question. Because the instinct here is to move that 1, because we said reverse bedmass. The issue is it's underneath the radical sign. So before you can move things away from the radical sign, you have to get rid of the radical sign. Anything under the radical sign is forever stuck there until you get rid of that radical. So we can't move that 1 yet. Now what do we have to do? We have the square root of x plus 1 is equal to square both sides. Square both sides. And we have x plus 1 is equal to 4. Minus 1 from both sides. X is equal to 3. What's the last thing we ask ourselves, Patrick? Oh, Gainer bailed you out, Patrick. What's the last thing you do now? Check to see if it's a reasonable answer. Is it?
Yeah.
Yes. Okay. Practice question 1A. Square both sides. That's the first step you're going to do. Then you're going to add 1. Sorry, then you're going to add 2. So your answer is 27. Question B. Square both sides. Get 25. Subtract 1, 24. Divide by 3. Your answer is 8. Okay, the next question. Well, if you don't care what I have to say, then I'm not going to sit here and try to talk over you guys. Square both sides, you get 16. Subtract 2, you get 14. Divide by -7, your answer is -2. D. Square both sides. You going to listen? There's 10 different side conversations going on. If you're so good at it that you don't need to listen, then I'll just whip through them for you. But I think you guys want to go through them slowly. Yeah. Okay. First thing you want to do, get the radical by itself. Is the radical by itself? Yeah, it is. It's isolated to one side. Square root x minus 2. One side, all by itself. So the first step's already done for you. So what do you have to do? Square both sides. When you square both sides, the square and the square root cancel. So you get x minus 2 is equal to 25. Now what do we have to do? Plus the 2. So add 2 to both sides, and you get x is equal to 27. B. What's the first thing you need to do? You need to get the radical by itself. Is the radical by itself?
Yep.
Yeah. There's nothing else attached to it. So that's perfect. So what do we have to do to get rid of the radical? Square both sides. Kind of a common theme. Square both sides. Goes away. On the other side, we've got 25 again. So we've got 3x plus 1 is equal to 25. What do we move next? Reverse BEDMAS. The 1 needs to move next. So you subtract 1 from both sides. Remember, reverse BEDMAS. So 3x is equal to 24. And now what do you need to get rid of? The 3. How do you get rid of the 3? Divide both sides by 3. Divide by 3. Divide by 3. X is equal to 8. Is that a reasonable answer? Yeah. Awesome. These really don't get any harder, in all honesty. In this course, I don't think we ever do more than square roots. And there's only so many operations they can throw at you. So these really don't get harder when there's only one radical sign. Go ahead and try to do these next 4 by yourself. I'll put the answers on the board. But they don't get much harder than this. Not when there's one radical.
They give you cube roots too.
Do we do cube roots in the future? Okay.
That's like, I think I went through this.
I can remember if that's this course.
I just can't remember how to work the circles. I'm trying to look in front of you. See this? So you want to wait, it's not an extraneous root. Because if you times it by the -7, then it would put it on there, so it's not extraneous. Check your math. Okay. Wait, you're recording nothing.
The first one, the radical's already isolated by itself, so you square both sides. That'll give you 16 is equal to 2 minus 7x. You subtract 2 from both sides. That gives you 14 is equal to -7x. You divide by -7. You get -2 is equal to x. The question is, why is that an acceptable answer if we're square rooting? Why can you have a negative? And the question is answered by actually trying it out. So if you look up at that question and you plug in -2 for x, it gives you 2 minus -14. Minusing a negative gives you a positive. So it's 2 plus 14. That's why it works out. You have, just because it's a negative doesn't mean it won't work. You have to actually test your answer and see if you can square root it. E, you've got the radical already isolated by itself. You square both sides. You subtract 1 from both sides, then you divide by 2. And you get 4 is equal to x. If you have a question on any of these, let me know. E, we did not have the radical isolated. We had to move the 2 over. So we added 2 to both sides. We then squared both sides. Then we subtracted the 9, and then we divided by 5. X was equal to 18.
I just like, so if the F
your answer would most likely be, I write D and E does not exist. And that's all you would say. There is no answers. F. The radical is not by itself, so we had to move the 1 over and then square things. Again, we work our way through it. We get x is equal to -5, which again, because you're subtracting a negative, turns it into a positive. That does work. Okay. Here's another page step-by-step instructions on how to solve radical expressions with two radicals. Now, thank you. The problem is with two radicals, it's never always like cut and dry. It can kind of look ugly on you, but that's okay. At the end of the day, it's not going to be a big deal. As long as you can figure out that you want to get the radicals to a position where you can square it to get rid of both of them. And if that doesn't make sense, you're like, oh, that's okay. We'll do some examples to make sense of it. Once you get the radicals to themselves and you square it, everything's the same. Nothing changes. So let's just see an example, so I'll make life better. Look at this question. We've got radicals. We've got two of them. They're on opposite sides. If you were to square both sides right now, you would not get rid of your radicals. Because you're squaring binomials, which means you would get those ugly inside terms, and you would have some really messed up equation. So to be able to square this means you have to get the radicals all to one side. Yeah, we just have to get them to one side. In this case, they'll combine. In other cases, they might not. Now, I think we have a couple examples where that'll work. So, for this one, let's subtract 2 root x from both sides. Minus 2 root x from both sides. That will cancel on this side. On the left, it would leave you with 1 root x. And you guys are getting pretty good at figuring that out. 3 root x minus 2 root x. You only have 1 root x left. And you still have minus 4 equals 2. Those things haven't changed. Oh, plus 1. Actually, I don't have a 2, I have a 1. There you go. Now, we only have 1 radical. Now we treat it the same way we've treated all of them before. Move the 4 over. So yeah, you have root x is equal to 5. Because we added 4 to both sides. Now we square both sides, yeah. And London's got it. We've got x is equal to 25. Is that a possible answer? Yes, it is. That's a good answer.
How are you supposed to know?
You take your actual answer, so we got x is equal to 25. You take it and you actually verify it, meaning you put it in back into the question. Square root of 25 is 5, times 3 is 15, minus 4 is 11. Over here. 25, the square root of that, 5, times 2 is 10, plus 1 is 11. The left side is equal to the right side. It is possible.
And it's
Awesome. Yes, sir.
You can't have a square root.
No, yeah, that's a good question. Your answer will always be just x is equal to something. Yeah, it'll be a nice clear-cut number. Okay. Here's an equation that Bailey was explaining before. What if they don't combine? So, for instance, right now, we could move that to the other side. And we could have the square root of x minus 1 minus the square root of 2x plus 3. We could do that. We could get the radicals both on one side. But that won't help us, right? That's just going to make our lives harder. So what we want to do is just square it right now. You can square both sides right now. And it'll get rid of both radical signs. So when you have radicals that can't combine, leave them on separate sides and square them off like that. Here. This is what I'm saying. It's going to take a lot of questions and a lot of repetition to see tricks. Because sometimes you're going to want to divide radicals to be able to get rid of them. And we'll see a couple examples like that too. So this one, the radicals are on the 2 separate sides. If we squared both sides right now, we would get rid of both radicals. So do that. Square it, square it. On. Anytime you can get rid of your radicals easily, do it. Even if it doesn't seem like it's the best way to go according to our instructions. Now you have x minus 1 is equal to 2x plus 3, which is a pretty easy question. Get x by itself, we're going to subtract x from both sides. We get negative 1 is equal to x plus 3. We're going to subtract. So we subtracted 1x from both sides. That left us with negative 1 over here. And it left us with 2x minus 1x is just x. Plus 3. We then move that 3 over, so subtract 3 from both sides. So we get x is equal to negative 4. Is that a possible answer? No, it's not. Look at your left side of your equation. You have square root x minus 1. If you put in x equals negative 4 into that equation, you would have the square root of negative 5. Is that possible? No. Is this an answer? No. The answer does not exist. D&E does not exist. Yeah. No, there is no answer. That does not exist as your answer. Okay, just wait. Put up your hands, because I can't answer 6 people yelling at me. Does not exist would be an option. Yes. Negative 4 will almost certainly be an option. Does not exist will also be an option. Does not exist is the correct option. For any time that you would square root a negative. Run it. No, when you square it a negative, you get an imaginary number.
Yeah, but it's still. But there is.
We don't want to go into
imaginary
imaginary.
numbers.
Yeah, we don't want to do that.
It has to. Number line.
No, it's not on the number line. All that you need to know for now is you can't square root negatives. And if you do square a negative, you get it does not exist. You get error. Is that clear? Okay. Example 4. You can do on your own. You would square both sides and then solve it out. Nothing much changes. It's the exact same as the question above. Which of the following radical equations then determine the extraneous root? You need to know that word extraneous. Because in this case, it's asking you for the extraneous roots. So your answer would be the extraneous roots. It's asking what are the extraneous roots. So the question is, determine the extraneous roots. Yeah, that's telling you to find the roots that aren't possible. Yeah. Extraneous roots means they're answers that aren't possible.
But is there, when you go to solve it, like, there's one answer to it, like when you simplify all of it?
Yeah. Yeah. So in question 1, for instance, I see what you're saying.
Oh, so it's just telling you that it's not going to get more sorts.
Right. Yeah. So we did this first one. We square both sides. We get 4 is equal to 3x minus 1. We move the 1 to the other side. We get 3 is equal to 3x.
You get
Oh. I added. both sides by 3?
A fraction, not the.
That's a good question.
Okay.
So we've determined the radical equation and it's determined the extraneous roots. Can you do fractions?
Yeah.
Yeah. You can do square root of fractions. Can you do the square root of this fraction? So if we plug 5/3 into this question, would it work? Yeah, it would work. If you actually went through and did the math in the calculator, you would get an actual answer. Your actual answer would be 2. So, are there any extraneous roots for this question? No. So if the question was, what are the extraneous roots? The answer would be, there are no extraneous roots. Question B, question C, they're all the same thing. It's just all repetition. It's there for extra practice for you.
That's going to be different.
If the question was, because it really says, I can't move, solve the following, so we've solved it, and then the second part of the question is determine the extraneous roots. So we solved it, that's your answer for the solving it part, and then determining the extraneous roots, the answer would be, it does not have any extraneous roots. Yeah. Okay. These questions, nothing's changed. All still the same. It's just extra practice for you to be able to go through. These are key questions for us right now. So, the formula d equals the square root of 13h can be used to determine the distance of the horizon d kilometers from the observer at a height of h meters above sea level. Yeah, these are the questions you're going to get, so you need to know how to solve them. So I think an observation platform is to be built on a fire tower. The base of the tower is 100 meters above sea level. How high must the observation platform be so an observer's distance from the horizon is 50 kilometers? Good, because I don't either. So what we need to do is we need to look at the question, underline things that are important, and figure out what it's actually asking. Math is really good at just giving you a whole bunch of crap and confusing you before you even get to the question. But if you slow down, underline things, break it down, it's not so crazy.
You said the question, oh, I get it, just put the stuff in the equation.
For this one, not quite. It'll be close, but it's going to be a trick. So, the formula. I'm going to underline it. D equals the square root of 13h. Can be used to estimate the distance of the horizon. So that's what that formula is telling me. It's telling me how far away the horizon is from an observer at a height of h meters above sea level. So we've got, anyone can stand anywhere to see the horizon, right? So the idea here is that depending on how high up you are, the further into the horizon you can see, which makes sense. If the higher you are, the further you can see out into a field. Here it's the ocean. The higher up you are, the further you can see out to the ocean. That's your horizon. An observation platform is to be built on a fire tower. So they're going to build an observation deck that you can look off of. The base of the tower is 100 meters above sea level. That's going to be important. How high must the observation platform be? How high? So an observer's distance from the horizon is 50 kilometers. My suggestion is once you've underlined all your information, you're going to use it as a checklist to make sure that you've done everything in the question correctly and you don't fall for an answer. So the first thing you have, D is equal to the square root of 13h. Good, we've used that. The question is, how high must the observation platform be so an observer's distance from the horizon is 50 kilometers? Where would that go into my formula? D. They just gave you D is equal to 50. D is equal to 50. Perfect. We're going to check mark that off. So 50 is equal to the square root of 13h. We actually haven't done that. H is the height of the tower, and you're right. They've given you a height. They told you that the base of the tower is 100 meters above sea level. Good question. They're telling you where the start of your tower is. Now they want to know how high up are you going to have to go on top of that. So at the very end of the question, we're going to need to use that. We'll have to subtract it. Okay. We've used all these things. H height. We've used them all. We've got 50 is equal to the square root of 13h. How are you going to solve for that? What do you need to do? Square both sides. So now you have 50 squared is equal to 13h. Now what do I need to do? Divide both sides by 13. Divide by 13. Divide by 13. What's 50 squared divided by 13?
190. I think it's like 192.
2,500? What's 2,500 divided by 13?
192.3.
192.3? Okay. You must be 192.3 meters high above the sea level to see that far into the horizon. That answers how high, but the observation platform started 100 meters above sea level. So we subtract 100. And here's the reason why. The question was, how high must the observation platform be? The base of the tower was already 100 meters above. Now you built up from that point. So you're already at 100 meters above sea level, but we need to get to 192.3 meters. So how many meters do we have to build a tower? 92.3 meters. So the answer is 92.3 meters because we already started 100 meters above sea level when we started building the tower. Okay, got one more.
Question?
The period P seconds of a pendulum is the time to complete one full swing. What's a pendulum? Thing that swings back and forth. Yeah. Okay. The period can be determined using the formula that's underlined. It's going to be important. Where L is the length of the pendulum in meters. Approximately how long should a pendulum be to complete one full swing in 2 seconds? We've got a formula. We've been given a number. Where does that number go in this formula? The period P in seconds of a pendulum is the time to complete one full swing. 2 seconds is P. You need to be able to connect those things. 2 seconds is your P. So we can write this out as 2 equals 2 pi square root L over 9.8.
I wonder if they would be these are real.
I think this one is real. because I know what pi is related to, 9.8 is close to gravity. So I think this one actually might be real. This is no one. Yeah, well, it's actually missing a lot of this. I think this might be real.
Would you want to do like the square, or would you want to like work with the pi first?
Good question. If you look at this, what do we need to do first to solve it? We want to get L by itself. We're looking for the length.
So you divide by 2.
Divide by 2 pi.
So
Pi is a number.
equals divide by
Divide by 2 pi. That'll cancel out. 2 over 2 pi, the 2's will cancel out. So you have 1 over pi is equal to the square root of L over 9.8. Now what do you have to do? Square both sides. So we have square cancels out. Square, that square is going to apply to both the 1 and the pi. So it's 1 over pi squared. Remember, 1 squared is just 1. Is equal to L divided by 9.8. How do you get L by itself? Times both sides by 9.8. L is equal to 9.8 divided by pi squared.
Oh yeah.
That's an ugly answer, but that's your answer. So the length of your pendulum is 9.8 divided by pi squared. Not going to be a nice answer. You would just put it as that. That would probably be your multiple choice answer.
I would have helped.
Possible. Sorry, what? Yeah, these last 2 questions are typical questions we're going to give you on tests. Yeah, yeah. You're done once you have L by itself. The only tricks that you want to keep your eye open for, and this one doesn't have one. You want to keep track of your units. So they gave us P in seconds, but then they also gave us P in seconds. So it worked out nicely. That won't always be the case. So they can say P in minutes, and then give you a question in hours, and then you have to convert the hours to minutes. Just be aware of that. The other thing you will want to be aware of. Complete 1 full swing. They might not give you 1 full swing. They could say it takes 2 seconds to do half a swing, which means it would take 4 seconds to do an entire swing. This question gave us full swing, so it's nice, but it's not always nice. I'll come over and look.